Previously we introduced the Enigma machine, a cipher device at the heart of the German military's communication system in World War II. In today's video, we will look at how Alan Turing, together with his fellow codebreakers, cracked Enigma and decrypted the coded messages. Alan Turing was a brilliant mathematician. In 1939, Turing took up a full-time role at Bletchley Park in Buckinghamshire, where top-secret work was carried out to decipher the military codes used by the Axis. He played a key role in inventing a machine known as the bomb. This device helped to significantly reduce the work of the codebreakers. Before we dive into how the bomb works, let's first have a quick recap of the Enigma machine. Enigma has a keyboard to input plaintext messages and a lamp board that outputs the encrypted version. Each Enigma operator had a book of codes, which instructed them on how to set up the machine for that day. Operators sending or receiving the message should use the same daily setting to encrypt or decrypt. You may go back and watch our previous video on Enigma for more detail. Cracking the Enigma seemed an impossible mission, and yet it was no match for some of the brightest minds of the time. The bomb was designed by Turing to discover some of the daily settings of the Enigma machine, specifically, the set of rotors in use and their positions, the rotor start positions for the message, and the wiring of the plug board. The bomb weighed about 1 ton, was housed in a bronze-colored metal cabinet about 7 feet wide, 6.6 feet tall and 2 feet deep, and was mounted on casters. The bomb was an electromechanical device that replicated the action of several Enigma machines wired together. A standard German Enigma employed a set of 3 rotors, each of which could be set in any of 26 positions. The standard British bomb contained 36 Enigma equivalents, each with 3 drums wired to produce the same scrambling effect as their corresponding Enigma rotors. Each drum performed exactly the same transformation as its corresponding Enigma rotor. To be double-ended, each drum had 2 sets of internal wiring, each of which matched its corresponding rotor. For example, the drum corresponding to rotor A would have 2 sets of internal wires, each set corresponding to the internal wiring in rotor A. The wiring in the drums bridged the contacts of the outer and third rings, and of the inner and second rings. A bomb could run 2 or 3 jobs simultaneously. Each job would have a menu that had to be run against a number of different rotor orders. The drums were approximately 5 inches in diameter. Each drum had 104 wire brushes, which made contact with the plate. The brushes and the corresponding contacts on the plate were arranged in 4 concentric circles. The outer 2 circles, input and output, were equivalent to the electric current in an Enigma in one direction, and the inner 2 were equivalent to the current in the opposite direction. The 3 drums were arranged to replicate the Enigma scrambler, with the top one simulating the right-hand rotor, the middle one the middle rotor, and the bottom one the left-hand rotor. The top drums were all driven in synchrony by an electric motor. For each full rotation of the top drums, the middle drums were incremented by 1 position, and likewise for the middle and bottom drums. The drums were color-coded according to which of the 8 Enigma rotors they emulated. At each position of the rotors, an electric current would or would not flow in each of the 26 wires, and this would be tested in the bomb's comparator unit. For a large number of positions, the test would lead to a logical contradiction, ruling out that setting. If the test did not lead to a contradiction, the machine would stop for the operator to record the candidate solution. And then the operator restarted the run. The candidate solutions were processed further to eliminate as many false stops as possible. Hundreds of workers were responsible for operating the bomb machines. But it was dull and oppressive work. They worked long shifts in dark, stuffy rooms. A bomb run involved a codebreaker first obtaining a crib, a section of plaintext that was thought to correspond to the ciphertext. Finding cribs was not at all straightforward, it required considerable familiarity with German military jargon and the communication habits of the operators. Codebreakers made educated guesses at certain words that the message would contain. For example, they knew that every day the German forces sent out a weather report, so an intercepted coded message would almost certainly contain the German word for weather. They also knew that most messages would contain the phrase Heil Hitler. Looking for these patterns in the coded messages helped the team to calculate the daily settings on the Enigma machines. Another breakthrough came with the discovery that numbers were spelt out as words. Learning this prompted Turing to go back and review any messages that had been decrypted, where he learnt the German word for 1, Heinz, appeared in almost every message. Cryptological flaws within the Enigma were also exploited by the team. For example, a letter was never encrypted to itself, which helped reduce some of the possibilities by ruling out a number of cribs and positions, where the same letter occurred in the same position in both the plaintext and the ciphertext. Thanks to the Bletchley Park team and the bomb, the Enigma was cracked. But because of the secrecy of the project, hardly anyone knew about this huge effort until 3 decades later, some 20 years after Alan Turing had died. It's believed that the work of Turing and his team helped to end the war 2 years earlier than would otherwise have been the case. My name is Claytab. We create 3D animations on various topics. Go ahead, subscribe this channel for lots more animations just like this one.